Hi everyone, welcome back to Information Security and Management. Our topic will be your security architecture and design domain. Okay, so this is a deeper topic compared to your previous video regarding your physical security and of course your introduction to security architecture. Okay, let us start. Again, your security architecture and design looks at how information security controls and safeguards are implemented in your system in order to protect the confidentiality, integrity, and availability of the data that are used, processed, and stored in the system. Now, security architecture is also an important area in an organization that processes, transfers, and stores data. It is a unified form of security design that will help organizations address necessities and potential risks involved when using computer applications and network infrastructure. In this architecture, your experts, okay, specifically your IT experts, clearly outline the security design principles that should be used and detailed security control specification. Now, your security architecture and design should not only be known by, of course, your IT managers, your IT department, but it should be known by the entire organization. So, also, okay, in order that each of the members of the organization know their role, know their control measures, okay, know their specific guide on their system. Okay, so for the security architecture and domain, you also have your model. We will also be tackling your security architecture, the modes of operation, and of course your security models. Okay, your security architecture and design historically was started by Dr. Alan Turing, who invented the concept of Turing machine. That given the idea of electromechanical computational machines, and of course that led to your computers. Okay, and you have here von Neumann model, who wrote the computer and the brains that describe the system architecture for modern microprocessor computing machine. But of course we will not be tackling much more on your historical side of your security architecture and design. Of course, we are more on your function. Okay. On our previous video, some of your hardware components as well as your software components has been introduced to you. You have your central processing unit. Okay, you have your memory. In terms of your memory, you have your primary and your secondary memory. Of course, you have your input and output devices. You are also familiar with these items because as early as grade school, of course, I know that you've been tackling this one already. Okay, next one, you have your storage. All right. We will not be tackling so much, or we will not be focusing so much on your hardware components as well. Again, we will be more on your design on how the system is created or how the system in the company as well as the components, okay, and the designing of the system and control is created. And we are not more on this part, okay? Next, you have your operating system. This is already part of your software components. You have your input and output controller. You have your device driver. You also have, of course, the most important part. The most important part is your system programs applications. Okay. Next one is your mobile code using your Java. Okay. I'm not familiar with this one, but of course your IT professional are more familiar on this one and they have or they know this actually. But of course, again, I'm not going to focus on this one. And of course, you have your data or memory addressing. Okay, now you have your operating system, okay, and your different computing platform. Your computing platform or digital platform is the environment in which a piece of software is executed. It may be the hardware or the operating system. even a web browser and associated application programming interfaces or other underlying services or softwares as long as the program code is executed with it. Okay? Under your operating system, you have your user identification and authorization. You also have your discretionary access control, mandatory access control. This is already tackled earlier, okay, on our earlier topics. Now, our focus for this one is your operating system schedulings. Okay, let us start with your multi-programming. Your multi-programming is a rudimentary form of parallel processing in which your several programs are run at the same time on a uniprocessor. Since there is only one processor, okay, there can be no true simultaneous execution of different programs. Okay, you have your multi-programming. There is several programs running, but of course, there is only one processor. Next, you have your multitasking. Your multitasking is the concurrent execution of multiple tasks. So kindly highlight concurrent execution of multiple tasks. This is also known as processes. Okay, when you say task, they are the same as processes. Okay? Your multitasking is the concurrent execution of multiple tasks or processes over a certain period of time. New tasks can interrupt already started ones before they finish instead of waiting for them to end. Okay? As a result, your computer executes segments of multiple tasks in an interleaved, okay, manner, while the tasks share common processing resources such as central processing unit and main memory. Your multitasking automatically interrupts the running program, saving its state partially, okay, and loading the saved state of another program and transferring control to it. That is your multitasking. You can interrupt the running program or running process of the first task. Next, you have your multi-threading. Your multi-threading is mainly found in multitasking operating system. Multi-threading is a widespread programming and execution model that allows multiple threads to exist within the context of one process. So you just have one process, but there is a multiple threads. Okay? These threads share the processes resources but are able to execute independently. The threaded programming model will provide developers with a useful abstraction of concurrent execution. Multi-threading can also be applied to one process to enable parallel execution on a multiprocessing system. Okay, so after you multi-threading, you already have your multiprocessing. Your multiprocessing is the use of two or more central processing unit within a single computer system. The term is also referred as the ability of a system to support more than one processor or the ability to allocate tasks between them. There are many variations on this basic theme, and the definition of multiprocessing can vary according to context. But they are mostly functions, okay? Their most functions is on how the CPU are defined, okay? So this is actually a step by step. Number one, you have your multi-programming. Under the multi-programming, you have your multitasking. So as you do one task, you can do multi-threading and your multiprocessing as your last item. There, you have your CPU processing threads. Okay. Your module are called also your processing threads. The next item is your memory management for functional requirements. Okay. By the way, under your operating modes and processing states, you have your number one kernel mode. Your kernel mode, okay, during the kernel mode or in your kernel mode, the executing code has complete and unrestricted access to the underlying hardware. It can execute any CPU instruction, and reference any memory address. Kernel mode is generally reserved for the lowest level, most trusted functions of the operating system. The second mode is the user mode. So, is it there? Ito pala yung modes mo, no? The second mode is the user mode. Your user mode, okay, or in your user mode, the executing code has no ability to directly access hardware or reference memory. Running code or code running in user code must user code. It should be in user mode, okay? The code running in user mode must delegate to system APIs to access hardware memory. Due to protection afforded by this sort of isolation, it crashes in user mode or always recoverable. Okay? Your crashes in the user mode are always recoverable. Most of the code running on your computer will execute in the user mode. Next, we go to your memory management. Your memory management is the process of controlling and coordinating computer memory, assigning portions called blocks to various running programs to optimize overall system performance. Your memory management resides in your hardware, in the operating system, and in programs and applications. So let us talk about the 5 functional requirements for your memory management. You have number 1, physical organization. Physical organization, the memory available for a program plus its data may be insufficient. Okay? Overlaying allows various modules to be assigned to same region of memory and the programmer does not know how much space is available. Next one, you have your logical organization. This is the next functional requirement, your logical requirement. The programs are written in modules. The modules can be written and compiled independently, and different degrees of protection given to modules, and you share modules among the process. Okay? Next is your relocation. Your relocation, the programmer does not know where the program will be placed in memory when it is executed. While the program is executing, it may be swapped to disk and returned to main memory at a different location. The memory references must be translated in the code to actual physical memory address. That is your relocation or your relative. You also have another functional requirement called your protection. Your protection, these are processes that should not be able, okay, to reference memory location in another process without permission. Impossible to check absolute addresses at another time and must be checked at a run time. Your memory protection requirement must be satisfied by the processor rather than the operating system. Your operating system cannot anticipate all of the memory references a program will make. Okay? And lastly, you have your sharing. This will allow several processes to access the same portion of memory. Better to allow each process access to the same copy of the program rather than have their own separate copy. Let's move on. Okay. So the 3 types of your memory addresses, you have your physical, logical, and relative. Okay, this is different from your functional requirement because for the functional requirement, you have your physical, logical, and relative, physical organization, logical organization, relocation, protection, sharing. But if you talk about or if you ask about the type of memory addressing, you only have 3, physical, logical, and relative. Okay? You have here the types of your memory storage. Number 1, your real. And number 2, your virtual. Your real is a program application defined storage location in the memory and it can access directly to the peripherals of the devices. While your virtual, they are secondary storage or medium of devices. And For the types of the storage, the primary, meaning that is the memory directly accessible in your CPU, and you have your secondary, these are your non-volatile storage medium. You can have your CD, your disk, your flash drives, and the others. Okay, so for the virtual memory, you have what you call your paging and your swapping. Okay? Let's start with your paging. Your paging is the procedure of memory allocation where different non-continuous blocks of memory are assigned a fixed size. The size is generally 4 KB. Okay? The size is generally 4 KB. Okay? This is 4 to 8 bytes. All right. The paging is always performed between active pages. They are performed between active stages. All right. That is for your paging. For your swapping, okay, your swapping refers to copying the entire process address space or at any rate, the non-shareable text data segment out to the swap device or back in one. Your swapping is a process of swapping a naulit. Your swapping, okay, when you say swapping, this is the process of temporarily, okay, to secondary form, okay, main memory which is last or which is fast as compared to your secondary memory. Okay, it is a process temporarily to a secondary memory from main memory to which is fast as compared to second memory. The main part of your swapping is transfer time, okay, and total time directly proportional to the amount of memory swap. Let's try to differentiate swapping and paging. Okay? Your swapping, it is procedure of copying out the entire process. When you say paging, it is a technique of memory allocation. When you say swapping, it occurs when whole process is transferred to the disk. And when you say paging, it occurs when some part of the process is transferred. Kapag swapping, the entire process is copied. While for paging, it's only a part of the process that is transferred. Okay? Swapping can be performed without any memory management, while your paging is a non-continuous memory management. Your swapping is done by inactive processes, and your paging can only be done, okay? Only active processes can perform your paging. You cannot perform without any active process. And your swapping provides direction regarding solution, but your paging has no suggestion given regarding any solutions. Okay, let's now go to your information security model. Again, these are your storage devices. Um, you usually use your SD or micro SD memory cards and your flash drives. So I don't know if you were able to try using hard disk drives. Anyway, let's proceed with your security models. Information security models are method used to authenticate security policies as they are intended to provide a precise set of rules that a computer can follow to implement the fundamental security concepts, processes, and procedures contained in a security policy. This model can be abstract or intuitive. Okay, let us start with your Graham-Denning model. Graham-Denning model, by the way, please take note of these definitions. Your subject, okay, a subject requests service, an object provides the requested service, and the security model specifies the rules of behavior of a system. You have your access. This is the flow of information between subject and the object. Access capability. What is the subject or what the subject can do to an object. And you have your access control. We were able to tackle this during your access control topic, your DAC, MAC. Okay, let us start with your Graham-Denning security model. Your Graham-Denning model is a computer security model that shows how subject and object should be securely created and deleted. It also addresses how to assign specific access rights. It is mainly used in access control mechanism for distributed system. Okay? There are three main parts of this model: a set of subject, a set of object, and set of 8 rules. Okay? Again, it has three main parts: set of subject, set of object, and set of rules. Okay. A subject may be a process or a user that makes a request to access the resource, and your object is a resource that a user or process wants to access. We were able to define that earlier, so please don't forget. Next, we go to Harrison Russo Ullman, or HRU security model. Your HRU security model is an operating system level computer security model which deals with the integrity of access rights in the system. They are after the integrity of your access rights in the system. It is an extension of the Graham-Denning model based around the idea of a finite set of procedure being available to edit the access rights of a subject of an object. Okay? It is, of course, named after the three authors. You have your first author, Michael Harrison. The second is Walter Russo and Jeffrey Ullman. Along with all presenting the model, okay, these three authors also discuss the possibilities and limitation of proving the safety of systems using an algorithm. So you have also your information flow model. Your information flow model, or IFD, is a diagram that shows how information is communicated from a source to a receiver or target. An IFD can be used to model the information flow throughout an organization. An IFD shows the relationship between internal information flows within organization and external information flows between organization. It will also show the relationship between internal department and the subsystems. The next model is your Bell LaPadula, okay, security model. This model is a state machine model used by enforcing access control in government and military applications. So this was more adapted for military or government application. The model is a formal state transition model of computer security policy that describes a set of access control rules which use security labels on object and clearances for subject. Your security label range from most sensitive down to the least sensitive. Okay? And the next model is your, okay, again, by the way, your Bell Lapadula is, of course, concerned with the confidentiality of your information. Next is your BIBA model. Your BIBA model, or your BIBA security model, or BIBA integrity model, is developed by Kenneth Biba, and it is a formal state transition system of computer security policy that describes a set of access control rules designed to ensure data integrity. Again, it describes a set of access control rules designed to ensure data integrity. Data and subject are grouped into ordered level of integrity. The model is designed so that subject may not corrupt data in a level ranked higher than the subject or be corrupted by data from a lower level than the subject. Next, you have your Clark-Wilson model. Your Clark-Wilson model integrity model provides a foundation for specifying and analyzing an integrity policy for a computing system. Again, on the CIA triad, this is more concerned with the integrity of your information. Okay? This model is primarily concerned with formalizing the notion of information integrity. Integrity is maintained by preventing corruption of data items in a system due to either error or malicious intent. An integrity policy describes how the data items in the system should be kept valid from one state of the system to the next and specifies the capabilities of various principals in the system. The model uses security labels to grant access to objects via transformation, procedures, and restricted interface model. Next, you have your Brewer Nash security model. This model was constructed to provide information security access control that can change dynamically. This security model, also known as the Chinese wall model, was designed to provide control that mitigate conflict of interest in commercial organization and is built upon an information flow model. In the Brewer and Nash model, no information can flow between the subjects and object in a way that would create a conflict of interest. And you have your non-interface model. Okay? Let's now go to the security architecture and models domain. Now, in determining the architecture, okay, what is, okay, what is your Federal Enterprise Architecture or your FEA? Do you know this? Okay, your FEA. Your Federal Enterprise Architecture is constructed through a collection of interrelated reference model designed to facilitate cross-agency analysis of service provided to citizens and to identify duplicative investment, gaps, and opportunities for collaboration within and across federal agencies. So you have here your system architecture framework. Again, the purpose of your framework is to provide standards of terminology, description, and model to facilitate communication between, of course, okay, and among the members of your organization. I want us to focus here, okay, on your FEA. Let us start with your PRM. PRM is also called your Performance Reference Model. Okay? Your PRM is a standardized framework to characterize the performance of information technology initiatives and their contribution to the program performance. PRM can help produce enhanced IT performance information to improve strategic and daily decision making. It will also improve the alignment and contribution of IT to outputs and outcomes, thereby creating a clear line of sight to results and identify performance improvement opportunities across traditional agency boundaries. The next FEA framework is your BRM or your Business Reference Model. The Business Reference Model is concentrating on the functional and organizational aspect of the core business of an enterprise, service, organization, or government agency. Your BRM is a function-driven framework for describing the business operation and the federal government independent of the agencies that perform them. Your BRM provides an organized, hierarchical construct for describing the federal government's day-to-day business operation. So this is mostly used by government entities. Next is your SRM or your Service Component Reference Model. It is a business and performance driven functional framework that classifies service components as or with respect to how they support the business and or performance objective. SRM is intended for use to support the discovery of government-wide business and application service component in IT investment and asset. Next is your technical reference model. Okay? Of course, if you notice, I'm not reading your service area, service category. Okay, I am providing what your technical reference model is or what is your service component reference is. Anyway, let's continue. Your TRM is a component-driven technical framework used to identify the standards, specifications, and technologies that support and enable the delivery of service components and capabilities. Your TRM provides a foundation to support the construction, delivery, and exchange of business and application of service components that may be used and leveraged in a component-based or service-oriented structure. And I don't know if this is the last. Let's see your data reference model. The Data and Information Reference Model, or your DRM, helps to describe the types of interaction and information exchanges that occur between the federal government and its various constituencies, I should say. It should or it will categorize the government's information along general content areas specific to BRM, sub-function, and decompose those content areas into greater level of detail. And of course, ultimately, the data components that are common to many business, process, or activity. Your DRM model, okay, your DRM model will establish a common and commonly understood classification for federal data and enable information sharing between your agency. And the common data classification model will streamline the processes associated with information exchange both within the federal government and between the government and their external stakeholders. Now, taken together, your FEA reference model create a comprehensive government-wide framework. Okay, but of course, not only for government, for entity-wide framework for guide in the IT investment activity. So you have here your information security requirements, assurance requirements, and your functional requirements. Again, for your security control are the management, operational, and technical safeguard countermeasure that will be used on your organization, and they are designed to protect the confidentiality, integrity, and the availability of your information, and of course, to satisfy defined security requirement. Okay? Your security control is there for the protection of your CIA and of course for the maintenance of your CIA. The categories of your security control: number one, management or administrative control. This is implemented by your higher ups, okay, or your top level management. Your operational or physical control. This is implemented under the operation, the middle level management, or by the lower level management, and your technical control. Your technical control is also called your logical control, and this is already part of the tactical activities of the company. Okay, so that is your security framework and design. Don't forget your control. Don't forget the different model that we tackle. Okay, and expect a short quiz regarding this as well as your previous topic on your physical security.